Okay, so we started our Laws of Exponents study yesterday, and I just want a quick review with you some of the things that we talked about. First off, parts of powers. Okay, so if you open that door, it says a to the nth equals a power. Okay, and a is the base of that power, n is the exponent of that power. Okay. All right, and then we saw, what does that mean? It means to multiply the base times itself as many times as the exponent indicates. So this being 4 to the third means 4 times 4 times 4, which is equal to 64. Okay. And we saw that works with variables as well as constants. Okay, then we took a look at the zero power. The zero power says that any number raised to the zero power equals 1. Anything, is if they put that zero exponent on anything, doesn't matter what it is, it's going to equal 1. Okay. And then the last things we looked at were fractional exponents, or rational exponents is their other name. And what we learned is the numerator of our fraction becomes the power of our base, and the denominator becomes the index of our radical, or root. Okay. All right. So fractional exponents. Then we looked at negative exponents, and we said what you need to do there is you change the sign. So if it's a negative exponent, you change it to a positive exponent, and then you use the reciprocal. So another word for reciprocal is the flip. Okay, that's one of the easy ways to remember it, because x becomes 1 over x. 1 over n becomes n. Okay, so that's the flip part. And negative exponents are not allowed in a simplified answer. So if you get a negative exponent, you have to take this step to simplify it. Okay. All right. What we're going to look at today is we're going to be multiplying powers with the same base and dividing powers with the same base. Okay. So just to kind of touch on those, when you multiply the same bases, so a and a are our bases, okay, you add their exponents. So a to the 5th and a to the 7th becomes a to the 5 plus 7, which is a to the 12th. Okay. With dividing, right, dividing being the inverse operation, right, we do the inverse operation with their exponents. So we were adding here. When we're dividing, we subtract the exponents. Okay, so remember, it has to be the same base, or you can't start adding and subtracting. Okay, all right, so let's take a look at these laws of exponents in a little more detail. So here they call it the product of powers property. Okay, but so the names kind of depend on who's writing the textbook. Right? So we got to remember powers, exponents, product means to multiply, quotient means to divide. Okay? So what I really want you to get from all of this is when you multiply powers with the same base, you add their exponents. And so this is a little bit bigger. You can see 4 to the 6th times 4 to the 3rd is the same thing as 4 to the 6th plus 3, or 4 to the 9th. Okay? Which again would be 4 times 4 times 4 times 4, 9 times. Okay, and then if it's in a more algebraic expression, right, with just letters, a to some number m times a to some number n is equal to a to the m plus n. Okay, and one thing we have to talk about with quotients or division is we can't have a 0 in the denominator. Okay, so when we're dividing a by a, even though they have different powers, a can't be equal 0, because that would cause us to divide by 0, which is not possible. Okay? All right. Now, this power of a power property, we're not going to actually talk about today, but it was part of the graphic, so I'm just going to leave it there, and we're going to move on. Okay, so we just looked at the power rules, and so I want us to just kind of look at why they work for a minute. We have multiplying with like bases, and we have division with like bases. Okay, and we said the rule for multiplying was if you were multiplying, say, a to the third times a to the sixth, you would change that to a to the 3 plus 6, which is a to the ninth. But I know some of you like to know why that works out, so I wanted just to remind you that a to the third means a times a times a, and a to the sixth means a times a times a times a times a times a. Okay, so we have 3 a's and 6 a's, and altogether we have how many a's? Oh, 9, right? And we're multiplying these 3 times these 6. Okay, so that's why we can simply say a to the 9th power. And then division, let's say we had a to the 3rd over divided by a to the 6th. Okay, and we would subtract, so a to the 3 minus 6, which equals a to the negative 3, which we said would be 1 over a to the 3rd. Okay. So why does that work? Well, we have a times a times a divided by a times a times a times a times a times a. Okay. All right. Now, we know when we're dividing, if we divide the same thing by itself, that's 1, right? So a divided by a is 1. A divided by a is 1. So I have 1, right? 1 times 1 times 1, or simply 1, left in my numerator. And then in my denominator, I have 1, 2, 3 a's. So if you don't like using rules, you can try and problem solve. All right, so here we have, it tells us to simplify, and I look and see that it's got parentheses, letters. I don't see any other symbols, but parentheses tell me this means multiplication. Okay, so on these first 6, I am multiplying the terms together, and my answer should be a single monomial, right? One term. Okay. So let's take a look here. The rule is if I have like bases, so I look here, x and x and x, all the same base. Okay, so then I look at their exponents. Nothing is written for this x, so I know that's an understood 1. So I'm going to take now x and add the exponents. So 1 plus 2 plus 7. Okay, so that's going to give me x to the 10th power. And that's my simplified monomial. Okay, let's look at another one. This one's a little interesting because it has different letters, right? It has L and K, so we have 2 different bases. We have L as a base, and the exponents are 2 and 3. And then we have K, our other base, with the exponents of 2 and 1. So my final answer would be L to the 5th, K to the 3rd. Okay. And then the last thing we want to look at is, well, what happens when they throw in the numbers out front? Those aren't bases. Well, they are bases, but the exponent is 1. They look a lot like coefficients, right? Because they're in front of the variables. Okay, so the easiest way to deal with the numbers is the numbers are still the numbers you've known since elementary school. Okay, so when we're multiplying, we're just going to multiply the coefficients. So here, the 5 would get multiplied times the 4, the negative 2 times the negative 4, and then 7 gets multiplied by the understood 1 here. And technically, we've been having a number here, right, because the understood coefficients for the others were 1, and when we multiply with 1, nothing changes. So we didn't need to write them in on that one. But on this one, when we have one coefficient and the other one's not visible, it's probably a good idea to go ahead and write that down. Okay, so I'm going to take a look at this one. So we're going to say 7 times 1 just regular old multiplication. Then we're going to take our base a, which has an exponent of 5, and we have our a over here, which has an exponent of 2, so we're going to add 2 to the 5 that we already had. Then our next base is b, so we write down the b, exponent is 2, and then the exponent of our next b is 3. All right? So we end up with 7, a to the 7th, b to the 5th. All right? Okay, now, I'll leave the rest of these for you to work out. The questions here at the bottom are using geometry, but to kind of talk about the same type of problem. Okay, so one thing I'd like to do is, since they're asking about the area, is make sure you know the area formulas. Area of a rectangle is length times width. Okay. Area of a square is s squared, where s stands for a side. Okay. And then the area of a triangle is 1/2 the base times the height. So on a triangle, this is one I'm going to talk about because I think the other two y'all are more familiar with. With a triangle, the base can be any side, but since they only give us this one side with a value, that should be our b. Okay, and then the height is the distance from the opposite corner to the side in which that line makes a right angle with the side. Okay, so this is our height here. So if we put that together, we have 1/2 times 9p cubed times 4p. Okay. And if that's not a 3 on your paper, I apologize. I'm having a little trouble reading. My eyes are not as young as they once were. Okay, so if we use what we learned up top, right, we take the numbers and multiply them together, our coefficients. So 1/2 times 9 times 4. And then we take our bases, so which in this case is just p, and we have a 3. And then over here we have the understood 1. Okay. So 1/2 times 9 times 4 is 18. And then p to the 4th. Units squared is what we like to say when we're talking about area. All right, so you might want to go ahead and pause the video here and work the remaining questions on this side of the worksheet. When you come back, we'll take a look at the back side of the worksheet. Okay, so you're back. Now, the second property we looked at was for division, right? And with division, if you remember, we subtract the exponents. So we look at all our letters, and for this one, we only have A. Here we only have M. Over here we have P and N, right? Y, X and Y. So there's a variety of things going on. Okay, so when we start off, we take our base, in this case A, and we're going to subtract the exponents, and we subtract top to bottom. Okay, so 2 minus 1, which is 1. A to the first, or simply A. When we look at, say, question 4 here, we have X to the first, right? And on both of those, so we'd have X to the 1 minus 1, Y to the 6 minus 4. So we end up with X to the 0, Y to the second. But now you've got to remember back to our lesson yesterday about the 0 power. Anything to the 0 power equals 1. So our actual answer here is simply y squared. Okay. Next one, let's talk about 7 and 8 because they have negative exponents. And we said we can't have negative exponents in a simplified answer. But I will tell you, I wait till the end to deal with negative exponents because sometimes when I'm working the negative exponents go away. Okay, so I would look here for this, for number 7, I would say f, they're both f's, and negative 7 minus 4, right, which is the same thing as f to the negative 11. Well, my negative exponent did not go away, so I'm going to have to deal with it. And remember, we take and we write the reciprocal, so 1 over f to the 11th power. And that is my final answer. Okay. All right. So let's take a look then at 10, 11, and 12, and you notice, well, even 9 has as well. Oh, and 6 did. So I guess I could have started talking about them. But they all have coefficients. So this means division, right? 48 divided by negative 6. Well, that's going to happen just like it's always happened. I'm going to have us take a look here at number 12 because I find number 12 to be very familiar, and hopefully you do too. We looked at it yesterday on the other worksheet, and I said, you know, we're going to learn how to simplify it some more. Well, today's the day we're going to learn to simplify it some more. Okay, so we look at this, we analyze the whole thing and take into account there's numbers, there's a 0 power, there's negative exponents, and so how are we going to deal with those? Well, we take the coefficients and we just divide those. So negative 15 divided by 5 is 3. Then we remember that anything to the 0 power is 1, and when I multiply by 1, right, that doesn't change. Okay, I left off my negative sign. Sorry about that. All right, then we have u to the negative 1 plus, minus 3, okay, which would give us negative 3 to the u to the negative 4. So we want to rewrite that to get rid of the negative exponent. So we're going to have to do the reciprocal. Negative 3 doesn't have a negative exponent, so we write negative 3 above the fraction line, and then u to the negative 4th would be written below, except now it's positive 4 because we've rewritten the negative exponent as a positive exponent. All right, so now you should get the rest of your assignment finished.